Coming up on this episode of the IoT Inc. Business Show.
And then we come in and the tech guys, that are the company are passive aggressive, and it takes a lot of time to build up trust and say that we're not here to replace you. Everyone's objective, every consultant's objective should be to bring in skills that are missing on the client side while capitalizing on the skills and the knowledge that the client has better than anyone else in the world.
All right, let's talk building an IoT product or system. Time to cycle through concept to ideation, to proof of concept, to prototype, to MVP, and then finally to end product. In this episode of the IoT Business Show, part 1 of 2, I speak with Yuriy Pryadko, who shares his practical experience on the 6-step journey to manufacturing or deployment. In part 1, we lay the foundation using an interesting example of an IoT system in the fitness space, prepping us for episode 2, where we quantify the process.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com.
With me today on episode 37 is Yuriy Pryadko. Yuri is Director of Customer Solutions at Cogniance, with experience spanning product and process design, hardware, and software development. Before his current position, Yuri led the project management office, tailoring industry-standard approaches to each customer's needs. I met Yuri at the Designer of Things conference a few weeks back, and I thought, after talking to him, he'd be a great addition to the show. Yuri, welcome.
Thanks, Bruce. Thanks for having me.
So I saw your degree is in computer systems and networks. Wow, I mean, it sounds like that could be a degree in IoT tech.
In fact, you are not very far away from the truth. It was, it was an engineering degree that spanned both the software part of those systems, but we also did a lot of work on the hardware part. In fact, we did some amazing work. It was from my degree was from the National Aviation University. You've seen that, and we actually did some amazing work for the pretty old school analog computers that were installed in the airplanes back in the 50s and 60s that we still had in the labs.
So what do you mean? You had the radio systems in the labs that you were just playing around with, or you were talking about the radios in the planes themselves?
I'm not talking about radios. I'm talking about the analog computers that were used to to calculate the position of the plane, etc.
Okay. And you had those in the lab, or you were actually using the ones that were being used in the air?
No, in the lab. I actually never. No one let me fiddle with the one that was in the air for good reasons.
Yeah, probably. Well, it kind of reminds me. I remember when I bought my first iPhone. We're talking the one with the curved black plastic back, and that was like a long time ago. And I think at that time they were making the analogy between the computational power of the iPhone and the entire NASA computational power that it took to put a man on the moon in 1969. So I'm assuming there's some degree of similarity there.
Oh yeah, Oh yeah.
Just in terms of the power, that you're working with, a very low from the 50s. I would imagine that's going to actually be obviously before, way before the moon landing. So it's probably like not even the power of one of the chips or one of the sensor chips in the iPhone or something.
Well,
like that.
if you're talking about MIPS, of course, right now we have immense power in our pockets. But analog systems, and this is actually very relevant to IoT, have a lot of benefits when it comes to real-time data processing. And when you have a plane, flying in real time, and when you don't have powerful digital systems before they got sufficiently powerful in order to be able to handle all the analog to digital and back. Actually, analogs were much better suited to handle the tasks that a typical plane would have.
Interesting. Yeah. Okay. But extrapolate on that a little bit. Like, what is the characteristics of an analog system that'd be more beneficial than a weak digital one, I guess?
So analog system deals with the continuous flow of information. There is no frequency with which you make the signal discrete in order to process it.
Right. No sampling.
Exactly. There is no sampling involved. And when you're trying to control for probably rapid changes, I wanted to say small changes, but rapid changes in any variable you're talking about. For example, when you're controlling the ailerons on the plane and you're in turbulence, for example, analog systems are much better in immediately responding to whatever conditions you throw at them, as opposed to digital systems that are limited with that sampling frequency. You remember that the sampling frequency has to be twice higher than the frequency of this signal, at least twice higher than the frequency of the signal you're processing. Otherwise, you'll be losing information.
Yeah, the Nyquist frequency rate, I think, is what it's called.
Exactly.
Yeah. No, that's a good point. It's a continuous system, and I'm gonna ask you in a second about maybe you're going to go in the sensor area, but it's quicker. However, what you can do with an analog circuit is going to be less sophisticated. However, quicker. So if you're doing things that are less sophisticated but need to do them quickly, then I imagine, the analog kicking it back old school would work really well.
Sometimes, yes. And nowadays, if you fast forward to 2015, you still have a lot of analog sensors that you still need to capture. They are cheap, which is a big deal when you're talking about, hundreds of thousands of endpoint devices deployed in the field. The 1 cent versus 2 cents becomes a big deal.
Well, I guess it depends on what your definition of sensor is, but aren't all sensors analog sensors? I mean, you are converting some energy into a DC current, or are you saying some of them are actually converting directly into digital?
Well, you're actually right. All of the sensors will capture the analog signal first. And then you will convert to digital. But the conversion part also takes energy, and you have to do that. So if you're capturing analog values and then you're doing the analog to digital conversion somewhere upstream, well, I don't really see a use case where that can. Right now we are in a digital world.
Yeah, we're definitely in a digital world. Well, why don't we talk a little bit about yourself? Give us a little bit of background about yourself and your history in IoT.
So my name is Yuriy Pryadko, and I'm one of the founding members of Cogniance. And what we do at Cogniance is we, as you said when you did the great intro, thanks for that. Is we specialize on the end-to-end projects spanning both design and development of hardware and software. Think of it as as a combination of consulting and outsourcing, figuring out what to build, but also helping build it. And
Right.
Since I've been doing that for many years now, we will be turning 10 next April.
Oh, geez. Okay.
Yeah. It actually allowed me to work with some of the I'd say some of the greatest companies in a number of markets, in the number of IoT markets, such as automotive, such as connected health and fitness, smart home automation, and smart energy is another big vertical for us. So I've seen those products being developed on all of the life cycle stages, from the back of the napkin sketch to the actual production deployment. And of course, I've seen the highs and lows of what works and what doesn't, and that's basically what I want to share today.
Yeah, no, I'm looking forward to digging into it, because that's exactly where we are right now. In the podcast, we're in the middle of a mini series on working with discussing the issues with system integrators and product design houses. And I like your perspective. And when we were talking, that's what I thought was really a good one. Your perspective on being able to take it, like you said, like back of the napkin all the way to production. Before we get into that, though, we know a little bit about you. We know a little bit about your history, but tell us something that that most people wouldn't know about you.
Let's see. You mentioned radios, right? When I was talking about those analog computers, I actually have a story from my childhood.
Okay.
So I was growing up in Ukraine, which was a part of Soviet Union at the time. When I was probably 7, I don't remember exactly, I decided to put together my first IoT product.
Jeez, you're okay.
I'm kidding.
You may have won the award here. I'm talking to a lot of guests that they've drawn back, and everyone could kind of say, "Oh yeah, I was an IoT because of this." But 7, all right, I got to hear this. All right.
Well, it was not exactly an IoT. I'm kidding, but it was electrical. It was I was trying to put together a radio, and the supplies were scarce. We didn't have Radio Shacks on every corner, right?
Oh, no.
So I actually didn't have batteries, so I decided to make one. I took some zinc from the dead light bulb, some copper wire for another electrode. I stirred up my own electrolyte from the kitchen salt. I put it on in a jar, and I still remember, as if it was yesterday, the moment where I connect the voltmeter and the needle moves. I felt like I can do everything now. I can conquer the world. So here I am. I'm helping my clients conquer the world with innovative products, and that's where it all started.
Yeah, no, I like that. And it's interesting because at age 7, the Soviet basic science is strong. I mean, if you're already understanding how to make batteries at age 7, I'm trying to think. I don't remember myself, but I can think about my kids. But I don't think they got into that level of chemistry or physics, however you want to look at it, until a bit later. So that's kudos to the Russian, or the Soviet, I should say, education system.
The education was and still
Science
is very
education.
STEM focused.
Yeah.
So you cannot get a liberal arts degree without taking a little bit of calculus. A little bit.
That's interesting, though. I don't know how it'd play, although, maybe I can.
I mean, you don't have to be, go all the way, but a
little bit of calculus never hurt anybody, though.
Exactly.
Right? Even a poet.
Exactly. World would be better if every single person would know a little bit of calculus.
You know what? I think I agree with that, actually. But just try telling that to my daughter. But anyway. All right. So what type of projects? So you've said some of the industries, automotive, connected homes, but give us just to frame things for listeners. What type of IoT projects do you normally work on, or have you worked on, or what's the focus now?
So we work on a range of products. We usually serve 2 big customer segments. It's either startups who come with us, come with an idea, come to us with an idea, and they seek help to bring that idea to the market. Or it can be innovation labs of bigger companies. So we have Xerox as a client, we have Panasonic as a client, right? And those big folks have their production facilities and the departments that are focused on, of course, on the efficiency and on bringing, on the manufacturing, etc. But they also have internal innovation labs, which are structured not unlike startups. That really work on the new groundbreaking stuff that will eventually, in a couple of years, trickle down to the market, to the products that the company will be making. So we would work with those innovation labs. But the specifics of working with a bigger company as opposed to a startup is startups usually start from blank slate. You design the product from scratch. You try to come up with something new, right? As opposed to a big company that may have legacy systems, may have previous generations of the product, and that changes the way you approach problems, because you have to make sure that you enable backwards compatibility with whatever infrastructure they're having. You make sure that you deliver products that will work in sometimes in deprecated environments, but still you want to make sure that they if the environment is from the 80s, you still do not have any right to design a product that will look like something from the 80s. You still need to design for a modern user, for a modern consumer, or a business user if we're talking B2B. But the expectations are really high from the user side right now. The bar is set really high.
Right. No, I mean, I think from a UX point of view, you're definitely right. But in the back end, you're going to have to tap into whatever you have to tap into. So now with innovation labs, is this a common theme that you're finding? Is there actually, do you have enough samples to say that innovation labs I guess I just haven't worked for a big company in a long time now. It's been probably since Microsoft. Is this a common structure within these larger companies, or is it just happens to be the ones that you've touched on, or the ones that you were dealing with?
Maybe there is a selection bias. Of course, maybe we are working with the companies that happen to have those innovation labs. But I would say more and more of the big corporations start to understand that the rigid formal structure doesn't lend itself to innovation. And in order to enable innovation, you need to lose the tie. You need to sometimes. It's interesting. I've been to Japan this summer, and they have a very strong, very rigid corporate structure, and they also try to play this game. They try to play Silicon Valley.
On Fridays, is it Dress Down Fridays that you mean? Or
no, they do have incubators, as they say, and startup accelerators. I've been to an IoT startup accelerator at KDDI and ABBA Labs, which was a big boys playground, which was millions of equipment crammed into a pre-limited space. And, it was all up for grabs. Just, dear startups, please come in and use this in order to do something. But when I asked, okay, this is like production grade, high end stuff. How do startups do it? They didn't have a good answer. So it seemed to me that they created this no tie dress code. Come to work in jeans and t-shirts, and they bought a lot of expensive 3D printers and CNC machines, but they don't really have. They don't really know what to do with it. It takes more than just stating that you want to do innovative and do something great. It takes process, and it also takes right kind of mindset, right kind of people. And I'd say the companies that realize the corporations that have realized it in time, and now is time. They they would enable the right people to, I'd say they would shield the right people from some of the bureaucracy that inevitably happens in larger organizations, in some more than in the others.
No, and I think what you're identifying is cultural, and even if you do protect and you put them in their playground and you tell them to wear whatever, still it's really difficult to change culture of people, and that's why often you'll see, and I think it first started happening with the automotive companies where they'd realize this. I think one of the biggest strengths is to realize your weaknesses, and so they would open offices in California. And I remember this was happening around 20 years ago when I was in the CAD industry, and we were starting to visit these offices of Toyota, of Nissan, in Southern California, near the art school, the California art schools that are down there. So that's interesting. And so, are you working with companies? Are they in the United States, or you said you're in Japan? But are you actually working with them based in other countries too, or is it mostly more local?
We are actually global. We have a lot of presence in Europe. We have a lot of our manpower actually in Europe, in Denmark, in Germany, and the German office is very much focused on automotive, as you can imagine.
Yes. Okay.
We have Poland, we have Ukraine, where I come from. So we do not have office on the ground in Japan, but we do work with the Japanese companies. Interestingly, people who want to not miss the train, I would say, they and especially corporations, the big ones that want to that have larger budgets than anyone else. Basically, they tend to open up offices in Silicon Valley because of the access to talent, because of the access to the infrastructure. Just when you breathe this air,
it's rarefied.
It changes your thinking. But air is not enough. What is very important, what is paramount in new product development, is having the right process. If you've never done something before, chances are you will not do it right from the first time. Do you remember how did the first time riding a bicycle feel?
Yeah. Well, I remember falling a lot.
I do remember my falls, and it involved a fence, and it didn't involve brakes.
Never a good combination. In fact, I remember once I had built myself a chopper bike. So that's the bikes with the long front end with the wheels far in advance. And I would, for some reason, always want to take my hands off the handlebars. And one time I did that and went right into a tree. So I wasn't a fence, but I was a tree, and I do.
That counts, Bruce.
That counts. So you bring up a good point. The innovation labs, and what I've seen is really three structures when you're working within larger companies. You have the startup structure, and I think this is, the analogy here is the innovation labs. You've got a center of excellence, which can work, and then you've got more of an advisory committee that's kind of like a consulting group within the organization. But I always, when I do my workshops and when I do visit these large companies, I've always promoting the startup mentality, which I guess is what you're saying is this innovation lab then.
Exactly. It's like a startup within a larger organization, being able to tap into the talent pool, being able to tap into bigger organization resources, but not constrained by the bigger organization limitations.
Yeah, and specifically the quarterly numbers and having to
not having to turn in the specific number at the end of every month. Quarterly is not that bad.
Yeah, that's true. You got monthly quotas as well. But okay, so I want to go back to the projects though. So again, give us some examples so we can just understand where you're coming from. Give us some examples of some recent IoT projects that you've been working on.
A couple actually. To give you, I'll give you an example from the connected health and fitness field.
Okay.
And that is actually a very very good example, because it spans much more than the devices that would talk to the cloud, but also the cloud infrastructure, but also the mobile apps, but also the third-party integrations, which are paramount right now.
Let's hear it.
So the company is called NetPulse. They're based up here in San Francisco.
Okay, NetPulse, yeah.
Uh-huh.
I like it. I like the name already. Okay.
Mm-hmm. And what they're doing is they provide back-end infrastructure for and also not only back-end, just infrastructure for the fitness clubs around the world.
Okay. Mm-hmm.
But you will never see, if you walk into a major fitness chain, and they have all the major fitness chains as their clients. If you walk into a major fitness chain, you will see a nice screen on your treadmill that would allow you to log in with your club provisioned user handle identity, yes, and it will allow you to record all of your workouts, track all the data, send the data as you go to the cloud to collect statistics, to analyze it, etc. But it will never be branded NetPulse. You will never see the name. It will be branded with the respective gym's name, and you will have a gym app on your phone that will allow you to access that data and log in and see the schedules and everything, all the collateral services that you would need. But the core value of NetPulse that they deliver is that they enable the fitness clubs to capture more data about the user, about their fitness routine than anyone possibly can. They capture all the data within the fitness club by having by controlling all of the firmware that goes into the machine, and by controlling all of the data transfer back to the cloud and the cloud infrastructure for the analytics. But what they also do is they integrate with third-party data sources such as Fitbits, such as MyFitnessPal, and the rest of the fitness apps and trackers. They have several tens of integrations on the list, in order to create the network effect, in order to create the end-to-end picture of the user's fitness profile, their preferences, and then based on that information, when you have that high level visibility with the very granular data that come in every day, even when you don't go to the gym on that particular day, you start to be able to enable a number of use cases, both on the analytics side, both for the user and for the sports club, but also gamification experiences, but also advertisement experiences, but also a number of value-added services that you can deliver to the user by knowing more, by having this net cast wide that grabs all the fitness data information about the user. You're able to deliver extra value to the end client, and of course by association, since you're enabling your sport club to deliver that. They're a B2B company, so sport clubs love them for those capabilities. That would be an example of a project where we would be responsible for the implementation on all of these stages. We help them do the embedded engineering on the fitness machines themselves. We help them with the mobile app. We help them with the device to cloud connectivity and the big data backend behind all those data collection and processing. I think that's a very good high level overview of what we are capable of doing.
So this is interesting. So you're saying that they're getting access to the embedded systems within each of the different Nautica, for example. They can actually access the firmware within different manufacturers' machines, or how does that work?
and Life Fitness,
right? Okay.
They actually their VP of product when we were launching this, he used to spend like probably 3 weeks in a month at Life Fitness's office, talking to them about the integrations, making sure that
interfacing with them.
Yeah, exactly, making sure that we're reading all their hardware inputs right, and it was. I'd say in general, I can generalize this experience. Third-party integrations are a big deal. They can be both the power that you have in order to create those network effects I was talking about, to draw information beyond your reach. Right. If you cannot plant a sensor somewhere, if you cannot get a temperature from a certain point in your home, if you're doing a smartphone system, how can you infer that information? Can you use lighting as a good proxy for the temperature? Will the sun heat this place up? You need to look beyond what's reachable to you in order to get the information that you need. And in order to do that, you need to understand what you're trying to accomplish first. And then sometimes IoT products I see on the market are solutions looking for a problem. You've got this, wearables are, dime a dozen right now. Wearables don't do much except for capturing, your activity data. All the value is in the cloud. All the value is how do you deal with that information.
Right. No, and I think, I kind of told you my philosophy when we met a couple weeks back, in that, there's connected products, there's smart products, but they're not Internet of Things products. And the difference is part of it is what you're talking about here, and then being able to bring to bear the power. And
I remember that conversation. Mm-hmm.
Yeah. And, the other thing I think for our listeners that Yuri is pointing out, which is an important one, is often with the Internet of Things, people are considering the sensors as being the only data source. And that can't be any further from the truth. And one way to access other data sources is through data services. And they can be accessed, I should say, with an API, for example, or some SDK. But it's going to be these data services that are available, plus the sensor data, that's going to give you this data that you need. Because like you said, what you should be doing is planning, what is it you're trying to do? So what information am I trying to produce? And that'll drive what data I need to get. That may be captured by sensors, but often that'll be captured by data services, right?
And you don't have to build that data capture pipeline at all.
That's right. Well, meaning you can just interface with it through an API or some other service. Yeah. And I think this is another, some people, if you think about it a little bit, this is what the power of the Internet of Things is digitizing the thing in a way that can interface with the internet. And the power of the internet, if we compare it with the time when I was a programmer, which is now many years ago, I love programming, and I still would love to do it and have the time to do it. It was probably my favorite job.
I'm with you, Bruce.
However, I was building stuff almost at the atomic level. We had a few libraries. I was in the graphics area, so we had, graphic libraries, a few of them. But often I'd be doing the low-level libraries. Now, when programmers come out, they have such power. The mobile apps that you can create, there's such power that's available. Why? Because of the same reason, right? That you can tap into all these services that are on the internet. And that is, maybe an unspoken, but an actual very powerful component of what IoT is. What do you think?
I believe it must be Bill Gates who said that once, and it perfectly summarizes that the biggest trick in software is using a piece of software that has already been written.
Yeah. I mean, there's a term for that. It's not reusability, but no, and that's exactly it. And I think the difference when Bill Gates was programming, and then today, is the magnitude of that software, and then the access of what you can get to it with the interfaces that are available today. The abstraction of the interfaces is just so much more powerful. Because it used to be almost like when you wanted to access these external libraries, and in my day it was libraries because it was more local, but now it's services because it's not local.
Yeah, microservices.
Microservices. I mean, it was complicated back then because almost just learning the APIs, just learning all the calls was an education in itself. And now it's been abstracted to the point it's a lot. It seems anyway, not that I'm rolling up my sleeves any longer, but it seems that it's far simpler to do this interfacing. And beyond that, what you're interfacing to is so much more powerful because now it's on the internet, right?
And by simplifying the access to the data, by simplifying the access to the services, to those microservices we are talking about, we are enabling more people. We are enabling more use cases to actually. We're enabling more people to work with that data. To give you an example, right. I know a bunch of data scientists who are not big fans of writing code. They are much more comfortable. I mean, they do write code since they have to, but they are much more comfortable on the conceptual level as opposed to actually going and implementing the algorithm that they've devised, not prototyping, but actually making sure that it is efficient, it is production grade, it's covered with unit tests. They don't want to worry too much about the engineering part of the job. And providing them the high level interfaces, providing them with the API. If you have the for example, we were talking about sensors. If you're providing if your network, the deployed network of sensors provides a RESTful API that will allow anyone to pull that data in read mode and do whatever they want with them in real time, it means that for that data scientist, pulling the data from the database or pulling the data from the field becomes essentially the same task.
Right. No, and that's exactly it. And when I speak to my clients or my students when I'm doing my workshops, it is this access to the data. And in the old days, I guess still the today days, but when you're choosing your sensors and the environment for your sensors, you want to get away from having to know how the data was collected. You don't want to know that, temperature is in registry number 1562, 2D array, and then slash, 5215. You want to have it abstracted, like you said, with a get and a put. And that has a lot of implications, not only on the development environment, but also on the application protocols, utilizing some sort of application protocols that these development environments can access so they can contextualize that information. And so this is, you touched on a very important point in terms of efficiency in a lot of different dimensions, and that is, and I guess it really comes down to this abstraction. What we're talking about is an abstraction of data. Yeah. All right. I want to get back to this. So it's interesting, but we're a business show here. So with regard to the fitness example, I get the system, and it's a sexy system. But what I want to know is, what was the value that they're pulling out of it? I mean, I almost thought I heard you say like they're going to be sending me ads when I'm on my machine, and I was shuddering at that thought. But what is the value that they're trying to produce with their IoT fitness system?
Huge.
But just measuring is not interesting, right? So, and I think you've identified that with quantify itself.
Quantify itself is one aspect, but for the club itself, you can predict by and this is the data they came in to us. When we were scoping this out, when we were in the discovery phase in the first workshops, we asked them, okay, you want us to build this huge thing for you. Why do you need it? And I remember them giving me a very specific example. By simply collecting and knowing the check-ins to the club, the data at the tourniquet on the entrance, right, where you check in with your card. By knowing and analyzing that, you can predict with like 90% accuracy almost when the user is going to quit.
Interesting.
So if you go,
I like that. That's not what I thought you were going to say. I thought you were going to say when they're going to come back, but that is not near as interesting as when they're going to quit. Obviously, specifically for the clubs.
Absolutely.
Or even for the athlete or for the person working out.
So for the athlete, there is another and to finish up that case. If you know in advance that the user have started training less intensely, chances are they were not feeling well, and it's an opportunity for the trainer to reconnect with the user, drop them an email, and say, "Hey, Mike, how are you? I can see you were you were not as strenuous as usual. What happened? Are you just taking
or maybe you're not even showing up as frequently, right?
But not showing up as frequently is a great leading indicator into dropping the club membership. And sometimes all it takes is just an email saying, "Hello, we haven't seen you for a while. Did you know that the health benefits of working out at least once per week are this, and this, and this?"
Yeah, no, I like that, and I think that is valuable. And you brought up a good one, they identified. And I would think even to with respect to churn and the cost of acquiring a new customer, I would think that it even be of value to them to say, "Hey, Mike, we've seen you haven't been coming as frequently, or maybe you're only bench pressing 150 pounds these days. But how would you like a free personal trainer? How would you like a session with a free session with a personal trainer?" And that might be something that, I'm just thinking out loud here, but that might be something that would get them going back to the gym and then maybe reignite and then not quit, which is really, I think, what the gym's from the gym's perspective is.
You are hitting a very good point, which is personalized insights that are historically were provided by personal trainers, is what people are after. I'm a big fan of working with a personal trainer myself. I prefer that to just going in and doing whatever I feel like doing today. But think of having collected millions and billions of data points about the specific exercise programs users had, and the effect that exercise program had on their endurance, had on their heart rate when they run a 5K, or on the way they can bench press.
Interesting. I'm liking this, because they're collecting that pre-workout data.
Yes, and post and during the workout,
and then but they're doing that correlation. I think is the point,
yes,
right? They're correlating
and then,
the pre with the performance,
and then you can devise the. And this where the data science comes in. You can devise the relationships that were not evident before, that you can automate. Instead of saying, "Hey, Mike," or "Hey, Jane, go and work with a personal trainer and throw in the session that would cost you $150, right? Maybe less if you're considering the cost base of it. But anyway, instead of doing that, you can spend 5 cents when you amortize the cost of the initial research over the amount of times you do that, and say, "Hey, Mike, here's what we think will get you back to speed," and we present them the information that is based on 100,000 people's data that are exactly like Mike. They are,
and trying to achieve the same goals potentially.
Yes, they don't want to to bulk up. Instead, they want to make sure they lose they lose weight, and they perform aerobically on higher distances, because for example, they're training for the marathon, right?
Right. Yeah. No, I mean, and this reminds me. My first Ironman. So I've done a number of Ironmans. My first Ironman, I had a coach, and part of it, this is when I was all hooked up with the Garmin. I'd upload my data, and he'd be looking at fatigue specifically and seeing, he'd be adjusting the workouts, the weekly workouts, the daily workouts based on fatigue, because he could see performance, but this is where analytics takes the place of the coach, is that he could see the curves and relate the changes in them to fatigue, and then realize that, you maybe need to pull back on the workouts as opposed to continue pushing forward, because ultimately he was looking at data, but he was the my coach was that interpreter. I liked the idea of being able to, and I'm trying to think. I think I was spending $150 a month. I think it was $200 a month with the coach. But sure, be nice to get that as part of my gym membership. That's for sure.
And that's exactly what NetPulse is enabling its customers to allow the gyms to provide this as a service. And now you said that you had Garmin, you had this data upload routine. You were all you spent some time on making sure you do this ETL, ingest, process.
Yeah, that's right. I was doing the extraction, transfer, and load. Yes, that's translate and load. I was doing that personally.
Yeah, and imagine your workout machine, your treadmill, doing that for you. Imagine your exercise bike doing that for you.
Right. No, I like it. Okay, well, that was great, Yuri. Thank you. That was a great part one. Before we sign off, and we are going to do a part two on this, before we sign off, where can our audience find out more about you and your company?
Well, I've given a lot of examples from real life, so I don't think I need to go further about company. You can go to Cogniance.com for more information about what we do and some of the examples that I've already used. As of me, you can always reach me on Twitter. You can always email me for any kind of advice or just to pick my brain on the next IoT product that you're envisioning or anything beyond that I can help with. I'll be happy to help.
Excellent. Well, we'll talk to you in part two.
Thanks, Bruce.
Well, stay tuned for next episode when I talk with Yuri on quantifying both the cost and the time for doing projects like the gym project and a whole bunch of other questions I think you're going to find really useful.
Okay, that was a good talk with Yuriy Pryadko. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support this show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is part 2 of IoT Preproduction from concept to product, again with Yuriy Pryadko. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Till next week, may your path to IoT business be a patient one.
You have been listening to the IoT Inc. Business Show.